Hi everyone, my name is Anne Francis. I'm the lead botanist with NatureServe, and I am presenting with my colleagues Leah Oliver and Kathy Gooden. I'll be speaking about the conservation implications of taxonomy using a use case of Trillium. So NatureServe is an environmental nonprofit. We focus on conservation, and we help to coordinate a network of about 80 programs throughout the Americas. Because of our mission of conservation, we collect, maintain, and disseminate high quality data with a particular focus on rare and imperiled species and ecosystems. So you may know us for our conservation status assessments or ranks. These assessments provide a relative risk of extinction using a numerical scale from 1 to 5, 1 being the most imperiled and 5 being the least imperiled. We also do this at 3 geographic scales using letter prefixes to indicate G for global, N for national, or S for subnational. If you're more familiar with the red list, our ranks are very similar. This is a crosswalk of how our ranks align with the red list categories. So as I mentioned, we have these conservation status ranks. And this is a screenshot of our public-facing website called NatureServe Explorer, and it is showing Trillium pucellum. You can see here that it is globally ranked G3 or vulnerable, but that its status at the state level varies considerably. In the red, you see states that consider it critically imperiled or S1, orange, imperiled or S2, yellow, vulnerable, or S3, and these two have not assigned a rank yet. So we use these nested status ranks to provide more complete information about how imperiled species are and where they might need protection. And so these status ranks are maintained differently depending on the geographic scale. So the global and national level are maintained by NatureServe, but the subnational or state data, including all the downstream spatial data called element occurrences, are maintained by the individual programs. So in order to aggregate all of this data, we have a data exchange process where information from our central biotics is pushed out to member program databases, and we receive their data in return. But underpinning all of this is the need for taxonomic reconciliation. Otherwise, we will make mistakes with our data aggregation and we won't be comparing apples to apples. We do have a shared data model in our network. And again, what underpins that shared data model is the taxonomic framework. So NatureServe Central maintains the taxonomy for the entire network. The taxonomy in our database, which is called Biotics, is concept-based, where every element has one circumscription or concept that distinguishes it from another, regardless of the name. And we know that name is not enough to distinguish among concepts. These are 2 examples that I like to use. One concept can have many names, as in the case of Lady Gaga, and one name can represent many concepts, as in the case of Madonna. When we were developing the Natural Heritage Network and the database to maintain all of this conservation information, there weren't a lot of conventions around to guide us. So we made up our own. We basically have 3 categories of classification status: standards, non-standards, and provisionals. We need to maintain a standard list of names in order to align data from all of our programs and for all of our species and ecosystems, but most importantly, to provide information that makes sense or is intelligent for our users and our stakeholders. We can't expect users to sort through the mishmash of different taxonomic concepts and know what to do with them. At the same time, we need to have a way to maintain concepts that are not accepted by the standard for various reasons. There can be legal status attached to what we call a non-standard or a need for a program to maintain that separately. So we do. We also have provisionals, which are elements that have been published, but we haven't had a chance to formally address. So getting back to our Trillium pucellum use case, Trillium pucellum is a beautiful spring wildflower in the eastern US. In one of the most broad treatments, Flora of North America, only one species is recognized with 2 varieties. And the species and the varieties are all considered vulnerable, or G3 or T3. Now we're going to switch to the most split treatment, which is Susan Farmer's dissertation. She recognizes 10 distinct species, and here they all are color-coded by their county distributions. So what are you supposed to do if you're a conservation organization that needs to attach conservation status ranks and downstream data? Well, the first thing is to align all of the different concepts of the relevant treatments. In this diagram, produced by Nico Franz, shows the relationships all the way from the broad treatment of Flora of North America to farmers, and then a depiction of what NatureServe is currently accepting. In the current NatureServe treatment, we accept 3 species: Georgianum, which is this little bit of gold right here, which is globally critically imperiled; Texanum, which is in the orange here, globally imperiled; and then the rest of it is still in Pusilum. However, we recognize 4 varieties: Monticulum, which is the dark blue, globally critically imperiled; Ozarkanum, which is the dark green, with the unpublished Alabamicum here; what's left of Pusilum in the light green, with the unpublished Patrickii; and then variety Virginianum, which is the blue, with the unpublished Palestris and Carolinianum. So the point that I really want to drive home is that the different concepts that we follow result in different conservation ranks. And this is absolutely important if you are a land manager trying to figure out what to do with the species on your lands. So when we look at the Flora of North America treatment, there are no imperiled taxa at all. But the current NatureServe treatment has 3 imperiled taxa: Georgianum, Texanum, and variety Monticulum. So in summary, I wanted to mention that NatureServe maintains a taxonomic framework for a network of programs because we have to maintain our conservation statuses and data. We need a concept-based system to do it. We have to reconcile taxonomy in order to do data exchange and to include all of that downstream spatial and conservation data with it. It's a very time-consuming and mostly manual process, and we would absolutely benefit by having more widely accepted standards on how to do this and having efficient technology. And my final take-home point is that taxonomy really does impact the conservation that's happening on all of our watches. So together as a community, by improving the processes and standards we have for reconciling taxonomy, the better we will do at conservation overall. Thank you.